Okay, dear students, now last year, that is 2025, JEE mains in January and April questions will be discussed, and on the topic quadratic equations. So in quadratic equations and expressions, this is the general theory. A quadratic expression ax square plus bx plus c, where a, b, c are all real numbers, a not equal to 0. If a equal to 0, we lose x square term. So it cannot be a quadratic. So a is not equal to 0. And ax square plus bx plus c is equal to 0, then it is known as quadratic equation. And roots of the quadratic equation, you know, x is equal to minus b plus or minus root over b square minus 4ac, which is denoted by either d or delta. It is called discriminant. And sum of the roots, if the roots are alpha and beta, minus b by a, product of the roots c by a, and difference of the roots, as we may subtract lesser from higher or higher from lesser. That's why to avoid negative, we are taking it as modulus of alpha minus beta. It will be root d by mod a. And formation of quadratic equation, when roots are given, x square minus sum of the roots into x plus product of the roots is equal to 0. And when a, b, c are real numbers, a, b, c are real, then if discriminant is more than 0, then the roots, both the roots are real roots, but they are unequal, distinct roots. If d is less than 0, in the root we get negative and we convert it into iota, imaginary number, and total root becomes complex actually. So d is equal to 0, then discriminant will not be there. The roots which are obtained are equal and they are also real. Suppose a, b, c are rational, purely rational, they are not real, rational. If they are rational and if the discriminant is more than 0 and perfect square, we can get again rational numbers. If the discriminant, we are getting positive quantity but not a perfect square, then under root value cannot be splitted. So that's why we say that the roots are conjugate to each other. In such cases, the roots will be of the form a plus root b, a minus root b, p plus root q or p minus root q. Similarly, in the case of a, b, c are real numbers, then complex roots will be p plus iq, p minus iq. But in the quadratic equation, if p plus iq is a one root, then p minus iq is another root, no other go. Similarly, p plus root q is a root, then p minus root q is another root. Okay, they are called brothers, bro formula. Similarly, if we write y is equal to ax square plus bx plus c as y equal to 0 and ax square plus bx plus c equal to 0, then we can take x-axis, and if the line intersects, if the parabola represented by ax square plus bx plus c intersects the x-axis at two distinct points, then we say that d is greater than 0, roots are real and different. Similarly, if it is intersecting at only one point, means two roots coincide, it exists, there exists only one root. And if it is not intersecting, means the roots are imaginary or complex. But in the case of a, that is quotient of x square greater than 0, then the parabola looks like this. At x is equal to minus b by 2a, it leaves a value 4ac minus b square by 4a, which is known as minus d by 4a, sorry. So minus d by 4a will be the minimum value, maximum will be infinity when a is greater than 0. Similarly, when a is less than 0, the parabola will be downwards open. Then at x is equal to minus b by 2a, the maximum value will be minus d by 4a and minimum will be approaching minus infinity. Okay, one more thing, location of roots is there. So I will write and I will share in the coming video. So you please note that, and mainly the questions from quadratic equations, especially finding the roots, finding the number of roots, third thing location of roots, especially on modulus forms, and fifth one on Newton's formula they are giving. So for the past 3-4 years we are getting on these 5 concepts. So last year, that is in 2025, April and January sessions I will solve. There are 16 to 17 questions among all the papers. So I will discuss those so that you will be in a position to know the models, so that you can attempt April exam very well. Thank you. I will start the questions discussion.